All right, today we're going to start to apply some of the things that we've been doing with writing equations, and we're going to start that by looking at what's called a scatter plot. So a scatter plot is a graph of bivariate data. So don't get too confused by the notation here, but let's just fill this in. A scatter plot is a graph, and using a scatter plot can help you see what are called trends in the data. Basically, we want to see, are things related to each other? So that's kind of what I'm looking for. Are things related to one another? So notice in these three graphs here, we see some patterns. It's really the same thing as slope. So when the data is going upward like this, when x increases, y increases, we say it has a positive correlation. When you see a negative slope where things are going down, as x increases, y decreases, we say it's negative. If they're just kind of randomly scattered all over, we say there's no correlation in that data. Basically, positive correlation means they're both doing the same thing. So we could change increases to decreases. If x and y are both going up or down at the same time, it's positive. But if they're doing opposite things, one's going up, one's going down, then we say it's a negative correlation. And anytime we have points that maybe are outside of that, we would call those outliers. So here we can see an example of a scatter plot. And it just shows the height and weight of the New Orleans Saints football players. So you can see as their height increases, generally their weight also increases, right? There's a little bit of a trend here. It looks like a positive correlation. When we look at this scatter plot of landlines, we can see that there also tends to be some kind of correlation, right? It's not a perfect line, but they tend to be going down. So this scatter plot shows a negative correlation, right? As one thing is going down, or as one thing is increasing, the other one is decreasing. So as the years are going up, the number of landlines is going down. As time increases, landlines generally decrease. And we say generally decrease because it's not a perfect straight line. We can see once in a while it does go back up a little bit, but for most of the time, they tend to go down. So when we're looking for patterns here, we want to use something called a trend line. So a trend line is used to describe the trend of the data in the scatter plot. What that would look like is if I were to just place a straight line on this data, notice it's not going to hit all the dots. But a trend line, we want to be as close to as many of the dots as possible. So today what we're going to look at is, can we come up with a trend line, and can we find the equation of that trend line? So that's what we're going to look at next. So flip your note sheet over, and at the top of that, you see some steps for creating a trend line. Now the first part of that would be to actually make a scatter plot. So that's what we're going to do here next, is we're going to take the data in this table and we're going to use it to make a scatter plot on the graph below. So this just shows the average cost of a jet boat in the years after 2000. So the year 0 really represents the year 2000. The year 1 really represents the year 2001. So this data goes all the way up to the year 2013. So let's plot these points on this graph. Now we're going to have to kind of approximate here a little bit because you notice our graph the numbers along the bottom, we're counting by 2s, so it's kind of hard to read here, but we've got a 2, 4, 6, 8, 10, 12, and 14, and then up the side, it's going by 5,000s, right? 5,000, 10,000. So when I go to plot 17,663, I'm really going to have to kind of approximate where that ends up. So let's put these numbers on our scatter plot here. So I want to plot 0 and 17,000. Well, 0, 17,000 would be right in here somewhere. 1 and 19,000 would be about there. 2 and 21,000. So here's 2, 21,000 would be just over 20. Then year 3, it goes down a little bit. It's right about 20,000. So we'd have a dot about right here. 4 is back up to 23,000, so approximately right there. Now notice they skip year 5 for some reason. So year 6, we're going to go up to 24,000. Should be about right here. 7 is all the way up to 27,000, so it's in between 25 and 30, so it's going to be about right here. 8 doesn't go up a whole lot, right? 28,000, so it's about right there. 9 is 29,000, so just under 30, about right there. 10 is at 32,000, so we got to jump up above 30,000. 11 all the way up to 34,000, which would be about right there. 12 is just above 35,000, so about right there. And then 13 is going to be right in between 35 and 40,000. So our scatter plot's probably going to look something like this right here. Right, we just took this data, we plotted. We can see there's a trend here, right? They don't line up perfectly, but it looks like it's a positive trend. So as the years increase, the cost of a jet boat tends to go up. All right, so now we want to draw a line of best fit. What that means is draw a straight line through the data. Now everybody's trend line could look a little bit different. Draw a line that's as straight as possible and as close to as many of the dots as possible. So I'm going to put a trend line on my data here. I'm going to draw a straight line, and I'm going to try to get it as close to as many dots as possible. But it's obviously not going to hit every dot. And I'll try and draw as straight as possible. Go ahead and put a trend line on yours. And now we want to try and find the equation of that trend line. So generally to find an equation, we need a slope and a y-intercept, slope and a point, or 2 points. And we've done this already. We found the equation of a line through 2 points. It's just our ordered pairs look a little bit different. Now don't confuse this. This is an ordered pair. It's the number 5 and the number 25,108. It'd make a little more sense if they kept that comma out of there. This is the number 10 and the number 32,752. So that's an ordered pair. So to write an equation, the first thing we have to do is find the slope. So I'm going to find the increase here. And how much did this increase if it went from 32,752, or actually 25,108, all the way up to 32,752? That would be an increase of 7,644. That's my top number, right? That's my change in y. Now, this one's a little bit easier. From 5 to 10, that went up 5. Okay, I don't want to use this type of number for slope. For a real life situation, it's fine to go ahead and convert this to a decimal. I know usually we try to keep it as a fraction, but when we're representing something that's supposed to represent a real life situation, it's fine to make this a decimal. Go ahead and take 7,644 divided by 5. That would give us 1,528.8. What we really just found there was slope, or that's going to be our m. Right? Our m, our slope, is going to be 1,528.8. What that means is every year the price of a jet boat goes up about $1,500. Right, now we need to finish writing the equation. So now we need to pick one of those ordered pairs. Right? And we're going to use the point slope form of an equation. So let's move this up here. It'll let me. There we go. Now I need to pick one of those 2 points, and I'm going to start with this form of the equation. Y minus y1 equals m times x minus x1. Hey, we just found m, so I know what I'm going to put in for m. I'm going to put in 1,528. I just need to pick one of those two ordered pairs. I'm going to pick the one with the smaller numbers. So this is going to be my x. This is going to be my y. So I'm going to write y minus 25,108 is equal to m. Well, m we said was 1,528.8. And then in parentheses, I'm going to have x minus x. My x was 5. I've just written that equation, right? I replaced my y with 25,000, my m with 1,500, my x with 5. I really would like this in a more simplified form, though, so I'm going to write it in slope-intercept form. So remember, there's 2 steps to that. I need to multiply everything in parentheses by 1,528.8. So I'm going to multiply that number by x, and then I'm going to multiply that number by 5, which is going to give me 7,644. And now I need to get rid of the 25,000 on both sides. So in order to do that, I'm going to add 25,108 to both sides. So these would cancel, and I get y is equal to 1,528.8x. Now I'm going to add those two numbers together, and I'm going to get 17,464. There's my equation of the trend line that I just drew. That's the equation of that line. Now what they would like me to do here is, can I use my equation to predict, okay, what's a jet boat going to cost me in the year 2025? Based off the data up there, if I want to buy a jet boat next year, how much is it going to cost me? Well, 2025, the year was our x value, right? This is where our years. If my graph went all the way out to 2025, how far up would it go? Well, again, that's my x value. I'm going to take the equation that I just wrote, y equals 1,528.8 x, but what am I going to put in for x? I'm going to put in 25 for the year 2025 plus 17,464. And now I'm going to use my calculator, and I'm just going to evaluate that expression. So I took my equation and I replaced my x with 25 because I'm trying to find the cost of a jet boat in 2025. So if I take 1528.8 times 25 and then add to that 17,464, and I'm just grabbing my calculator and doing this, I'm going to find out that y would equal $55,684. So if I wanted to buy a jet boat next year, that's, according to my data, what it would cost me.